Okay, so we have a special limit, guys, that we currently do not have enough tools under our belt to find this limit. Okay, so I'm just going to give it to you. So the limit as x approaches 0, sine of x divided by x is going to be 1. And I need you guys, very important, to memorize this. Okay, memorize this. Okay, you will be asked, and you're going to use it all the time. Now, another one I'm going to ask you to memorize is going to be the limit as x approaches 0 over cosine of x minus 1 divided by x equals to 0. Both of these I need you guys to memorize, okay? And then later when we know enough, we will try to go back and prove it. But right now we need to use it. So memorize them, please. That leads us to example 7. Are you guys ready? Determine the limit algebraically. Okay, now in your textbook, it says verify your answer graphically. You are not going to require to do it. Most of the homework, I want you to do it without the calculator. So please don't use a calculator. But if you want to see if your answer is right, then yes, you can use a calculator to work that out. So example 7 says, determine the limit algebraically. That means no calculator. But if you wish, you may use a calculator to see if your answer is right. But you need to be able to do this without a calculator. A, the limit as x approaches 0 over x plus sine of x divided by x. So remember, students, we have those properties, right? If we have a division or addition and subtraction, and we can't really do, it's too difficult to work it all out at once, then we can break them up. So the first thing I'm going to break it up is we have a common denominator, so I'm going to split it up as x divided by x plus sine of x over x, just like that, okay? Then next, we are going to simplify when possible. So this is going to say the limit as x approaches 0. It's going to say x divided by x is 1 plus sine of x divided by x. Then we are going to break it up some more. An addition in limit, we can rewrite it separately because sometimes that's just easier to do. So sine x over x. Well, guys, this is a horizontal line, okay? So if I said graph y equals to 1, it's going to look like this. So it doesn't matter what x is, it's just going to be 1. Okay, so y value is always 1. Now this part right here, the limit as x divided by x. If you guys, I'm going to pinch it really quickly. Whoa, yeah, right? I just said memorize it. So here we go. So as x approaches 0, okay, again, as x approaches 0, sine of x over x is 1. So this whole thing right here, students, becomes 1 because of the identity that I just said. Please memorize. So this whole answer, guys, go out to 2. Okay, B says find the limit as x approaches 1 over x minus 1 divided by x squared minus 1. Okay, so the first step, guys, when you're looking for the limit, you're looking for the y value. Okay, so the first step is always easiest if we can see if we can plug it in. When x is 1, 1 minus 1 divided by 1 squared minus 1. Well, that's 0 over 0. That's not unacceptable. We can't divide by 0, okay? So what we want to try next, students, is, hey, is it factorable? So limit as x approaches 1. On the numerator, it is not factorable, but in the denominator, that is a difference of squares, right? X is x minus 1 and x plus 1, okay? So x squared minus 1, difference of 2 square terms. This will allow us to reduce, so that's going to get reduced with that. So that will bring us down to limit as x approaches 1 as, now reduce, we have 1 on the numerator, then x plus 1. Now we can substitute this in, guys, okay? So when x is 1, we can plug it in. So it's going to say 1 over 1 plus 1, which is going to be 1 over 2. So the limit for this function as x approaches 1 is now a 1 over 2. Now let's fill out some really important stuff. Okay, guys, make sure you understand these next few steps here. What to do if you get a 0 over 0 from substitution. Remember, we try to substitute this, right? And we got a 0 over 0. So here are some guidelines. There are quite a few of these, so make sure you guys understand it really well. Step number 1, split into sum or product and see if special limits apply. Okay, so let's roll up really quickly. So for example, 7a, if we substitute x approaches 0, sign of 0, 0, 0, 0. So 0 plus 0 on the top is 0 divided by 0. This is another scenario where it's 0 divided by 0. So what we did here is we broke it up into the sum of two functions, right? Just like that. Excuse me, guys. Excuse me. Okay, so we broke it up and then we simplified. Now, after we simplify, we saw that there was a special limit, okay? And we apply that special limit. So I'm going to write 7a, C7a. C, example 7a. 2, factor and cancel. Factor and cancel. Cancel is the same as reduce. Now we did that in example 7b. We substituted in, we got a 0 over 0, that's not legal. We factor out the denominator, we reduce it down, and then we were able to substitute back in. So C, example 7b. Now example number 3. So number 3, I'm going to give you an example, i.e. find the limit as x approaches 1 over 1 minus square root of 1, oops, I meant 1 minus square root of x, all over x minus 1. Well, let's see if we can substitute, right? Remember, the first step is always easier if we could substitute the value of x in. But sometimes it doesn't work, okay? So let's try. Well, square root of 1, it's 1. So that's going to say 1 minus 1. 1 minus 1 because x is 1. Well, this is going to be a 0 over 0. So this is not going to help us out. So what do we do when this is the case? This is the unique one. So pay attention, okay? We are going to try to rationalize the numerator, okay? So we are going to rationalize the numerator. Okay, so that means we need to multiply the conjugate of the numerator. So what you multiply to the top, you multiply to the bottom. This will allow us to definitely have the limit as x approaches 1 on the top, because those are conjugate pairs. We just need to multiply the top and the last, right? The first two and the last two. So square root of x times x, square root of x is now just 1 minus x. On the bottom, do not FOIL this out. Leave these unFOIL, okay? Then on the top, I'm going to go further to write the numerator in order. I just don't like having the number before the variable. And then this will have, okay. Then if you look at the numerator, we are going to factor out a -1. Okay, so take out a -1 on the numerator. Then we are going to have x minus 1. This is by design, so that way we can eventually substitute it. Okay, so again, this is going to be reduce, reduce. So that's going to give us a limit as x approaches 1 of -1 now on top over 1 plus square root of x. Now by substitution, we can plug in your 1, okay? So when x is 1, it's going to give us negative 1 over 1 plus square root of 1 is 1, so that's going to be a negative 1 over 2. So finally, we can do this after we rationalize the numerator. Yep, we no longer rationalize the denominator, we now can rationalize the numerator. Next one, number 4. Again, pay attention to 4. 4 and 5 are both related, okay? 4 and 5 are both special cases. Find the limit as x approaches 3 from the right of the greatest integer function. Okay, remember the greatest integer function can be written like this, okay? The bracket. Either one. Your book uses this. When I type out the greatest integer function, I use those. So you guys all need to know that they're exactly the same. So let's kind of remind ourselves what the graph of y equals the greatest integer of x looks like. If you guys remember, these are the step functions, okay? These are the step functions. So, and I'm just going to make each unit here is 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 3, 4, 5. Okay. So if you guys remember, we have a step. This is a parent function. So we're going to start at 0, open circle, close, open, close, open, and so on. I'm just going to fill out my grid here since I already have those marks. Okay, same thing here. If that's a closed dot on the top, the bottom is open. Okay, so that's, okay. So we are asking, find the limit as x is approaching 3 from the right side. So that means we need to stand on the right side. 1, 2, 3. Here's 3. Right? And I need to stand on the right side. If I'm standing on the right side, guys, the y value is approaching 1, 2, and 3. So for this one, your limit is 3. Okay. Now be careful. 4 and 5 are related, okay? 5. Find the limit as x approaches 3 from the left side of your greatest integer function, which can be written as a bracket. So 3 from the left side and the bracket. Okay. So similarly, we are going to stand, okay, remember we're approaching 3 from the left, so we are going to stand on the left side and go towards, okay, 3. So because we're on the left side, we are hitting a y value of 2. So the greatest integer function is going to be 2 here, so be very careful. Now when we have a negative number, you have to be super cautious, right? So like 6, find the limit as x approaches negative 2 from the right of your greatest integer function. And then 7, find the limit as x approaches negative 2 from the left of your greatest integer function. Okay, these are all related, okay? So check this out. Let's go to our graph. Here is negative 2. If we're coming from the right side, your y value is negative 2. Okay, your y value is negative 2. But if we are coming from the left side, let me add one more tick mark. Left side. Oh, let me use this color. Just trying to use the same color. Open, close. Okay. If we're coming from the left side, guys, which is here, remember I'm approaching negative 2 from the left. Your y value is negative 3. So can you guys see that it's not the same? If it